Okay, in this video I'm going to take a look at these two maps, this one and this one. In fact, I only really need to look at one of them because they're basically the same map. The values might be slightly different, but they're basically the same map. Now, these could be considered to be EGR or exhaust gas recirculation maps, but they are looked at from a slightly different perspective, which is why they don't look like exhaust gas recirculation maps. Sometimes Winolds picks these up and sometimes it doesn't, and they're not always present anyway. Or what could happen is these might be present and the traditional looking EGR type map that I looked at on the previous video isn't present. Now what I'll do then is I will double click on this one and open it up so we can just see what's going on here. At the side here we've got engine speed in revs per minute as usual, and if I go over to there you'll see the numbers change to the original values, so they went up to 8,500, which as a engine speed is 4,250, and along the top I've got injection quantity milligrams per cycle, and again that's currently reading up to 55, but the original value would have gone up to 5500. We won't worry too much about that. Factors and offsets the same as usual, so there we've got 0.5 for engine speed, we've got 0.01 for injection quantity, so the same as they were on the previous video that I looked at, so I'll just get rid of that. And what we've got here is the same sort of output that we would have expected to see on an exhaust gas recirculation map, but it's not shown in quite the same way. What I've got are values which, if I look here, I've just put in are mass airflow as before, so I'm still using the factor 0.1, but these values, instead of having high values effectively what would look like they're around the edge, so normally you'd expect to see on an EGR map higher values at the start up here and then higher values at the end down here and a sort of dip in the middle, whereas in fact what we tend to have here are lower values building up to a high value, lower values building up to a high value, with the higher values more or less in the middle, which is the sort of opposite to what you would have seen on previous versions. Now this map is in effect still showing you the exhaust gas recirculation, but it's showing you values that the engine could expect for any given injection. So in other words, when we look at this we can say, well, here we are, we've got, let's say, maximum injection, which obviously that's not the maximum, but it's the maximum under the EGR control of 55 milligrams, and if we put that at somewhere around about what would be somewhere near the maximum performance of the engine, which is usually at a quite low rev, so anywhere in the 2,500 to 3,000 rev range, so somewhere in the middle here. So basically what we're saying, at more or less wide open throttle at high injection quantity, high engine revs, not maximum revs but high engine revs, what we would want is about 1,000 milligrams of air. So this map is showing us the amount of air that we could reasonably expect to have for our mixture for us to get good combustion. So it's a sort of cross between an EGR valve and a smoke map, because it's showing us the amount of fuel that's going to be injected, the revs that are going to be a result of that, and the amount of air that's needed to actually get that result of engine revs. And so it becomes fairly obvious that if we have a low amount of fuel injected, then we will not need anything like as much air, so the air value is much lower, and as we increase the amount of fuel we're injecting, the more air we need to put in. Now, depending on how the ECU has been set up, these two maps can be used to determine the exhaust gas recirculation instead of the ones that are here, which look more like the traditional exhaust gas recirculation map. So in other words, these can be considered to be just a different version of exhaust gas recirculation maps. I prefer to think of them as an air requirement map. So whenever I look at them, I think of them as air requirement maps, because the exhaust gas recirculation map is an air requirement map, but everybody calls it an exhaust gas recirculation map. So to distinguish these two from these, I tend to think of them as air requirement maps. They're used in virtually an identical way to the exhaust gas recirculation, so the ECU would just use these to calculate what the exhaust gas recirculation valve should be doing. The only reason you need to be aware of this is that sometimes you can decide that you're going to make changes in a file to the obvious exhaust gas recirculation maps, these, only to discover that you haven't actually made any changes at all because nothing has happened. And that is usually because the maps that are being used are not the ones that look like exhaust gas recirculation, but are in fact these maps instead. If you've got a Damos, you can obviously look this up in advance and try to work out which maps are functioning, but if you don't know for sure, then what you may have to do is set the traditional exhaust gas recirculation maps, all these, to 0, and then of course if nothing happens and the engine behaves as per normal, you know that they are not functioning, and so you probably need to look at these in order to make any changes. Again, in another ECU it might be that if you set these to 0, nothing happens because it's the typical EGR looking maps that are being used. So it varies from file to file. Okay, rather than go into any more detail here, because it's probably simpler for people to make changes and play on their own before they decide what to do next, so rather than go into any more detail, I'll stop there.